All right, so the very last thing that we're going to kind of review is what happens if you know one of the complex numbers in the solution, but you have to figure out the other one. So for example, if I want to add -8 plus 5i plus a plus bi, and I want the result to be a real number. Okay, so remember, complex numbers are made up of two parts. They have real parts and they have imaginary parts. So these two are the real numbers, and these two are the imaginary numbers. So when we add these two together, if we want the result to be a real number, then what that means is that the resulting has to have the imaginary part equal to 0. So we think about it like this. Okay, so we're going to be adding these two together. So -8 plus a can be anything really, as long as it's not equal to 0, because I want that result to be a real number. So it can be anything, and we can pick any number, right? So if I want this to be equal to 10, then I just solve this. So add 8 to both sides. And so a could be equal to 18, for example. Okay, so we could have 18. Now the other two, because that is the imaginary part, these two, when they add together, those have to add up to 0. Okay, because we want our answer to be a real number and not an imaginary number. So if we do 5i plus b, those two have to add up to 0. And actually, I'm going to take the I off of this one because we know that it has to be imaginary, so I don't really need that on there. So in order to get b by itself, you would subtract 5 from both sides. And so b would have to be equal to -5. So this would be 18 minus 5i. Now this is only one possibility. This one would have to be -5i because that's the only thing that's going to cancel out with the positive 5i. But this could be anything as long as it doesn't make this sum equal to 0. So what happens if, let's say that we want to do the same thing, but this time instead of wanting it to be a real number, maybe this time we want our result to be an imaginary number. So I'm just going to use the exact same the exact same complex numbers that we did before. So -8 plus 5i plus a plus bi. But this time we want the result to be, oops, the wrong thing. There we go. This time I want the result to be an imaginary number. Okay, so remember, an imaginary number means that the real part has to be equal to 0. Okay, so that means that these two parts this time, since those are the real parts, they have to cancel out. So -8 plus something has to be equal to 0. So if we add 8 to both sides, we get that a has to be equal to 8. So this would be 8. And then the imaginary part can really be anything as long as they don't cancel out to 0. Okay, so I could do 5 plus b could be equal to 10. It doesn't really matter what I pick for this number here, as long as the real numbers cancel out, so I'm only left with the imaginary part. So if we subtract 5 from both sides, then b would have to be equal to 5. So we would have 5i. So the complex number that we would be looking for, or one option, would be that a plus bi could be equal to 8 plus 5i for a solution.